Yeah, okay. So let me actually share screen with our class. Let's see. Oh, actually, oh no, that's not what I want. That's my actual Notion. Oh my God. Give me 1 second here. Gotta remember how to do all this. It's been a month. Here we go. Okay. Okay, so here's the Blackboard. You should be able to access the Blackboard now. And honestly, I don't like Blackboard. So literally, I just have this link right here to go to everything, to where all the web pages and stuff are. So if you click on that link, you should see something like this. And this is our course web page. This is the place to like to start. You can just save this link directly if you want to skip Blackboard. But you can always reach it from Blackboard. So yeah, this is me. People can see this share, right? Just like thumbs up or nod or something. Good. Should I make it bigger? Maybe make it bigger. All right, so this is me. I am in Searles, that's where our class is. Here's a Zoom link, which you are already at. I have a bunch of office hours. Basically, you can drop in anytime, just show up any of these hours, and I should be in my office sitting there waiting for you. So I have them every day of the week. I do have a lot of office hours. I don't know, I got one comment on course evaluations last semester that was like, King is always canceling or moving office hours, and it's annoying or something. And I'm like, all right, that's because I offer a lot of office hours. And so sometimes I have a meeting. I mean, it'll come up to conflicts and I cancel every office hour, but I still have lots of chances to see me every week. So do that. We will have a weekly study group. Actually, I know the study group leader is Teresa Andres. She's a senior math major. She's awesome. I haven't scheduled it yet though, so we'll schedule it. But I'll talk about, well, actually it's down here, I guess. I'll talk about that in a minute. I'll also talk about this Gather classroom where, since we're remote this week, I'll actually have office hours in here. And I wish we could do group work in here, but the free tier only allows 25 simultaneous users, and there's more than 25 of us in the class. So we'll just use, we're gonna do some group work on Wednesday, but we'll just use breakout rooms for that. But office hours, I'll show you this in a little bit. Okay, so we meet here. Well, we're not in Searles 215 today, but you know, we will be next week, hopefully. And just, a lot of students ask about this. I'm actually not using the Monday night lab slot, so you can clear that from your schedule. Of course, we may schedule the study group time during that time. So in which case, you might want to keep that time free. It's just an artifact of how we've done things, and I didn't want to teach at night, but there are also not many classes at night, so I just scheduled it at night just to get it out of the way. But part of the thing is to have more hours together, which I do like. I wish we could have more hours together, but one way I'm going to deal with that is there will be some videos you're going to watch outside of class and take notes on before class, like stuff that's just straight lecture dump that it's just, you can just sit and take notes on. That's not that important to do like when we're together. And so in some ways that will make up for the lab time not existing. We'll be watching and taking notes on some videos in advance of class. Okay, so let's see here. It's the weekly study groups, nightly tutoring. Oh yeah, so like I said, I have many drop-in hours. Oh, sorry, this is from last semester. I just have it Friday afternoons. I can edit this as we go because this is a live thing for me. You should not be able to edit it. Hopefully you cannot edit it, or else that's a problem. Yeah, so we'll have this study group, which it's totally an optional thing, but you know, it's just a nice extra resource if you want to go hang out and work on homework. And then it takes usually a couple weeks to organize, but there is calculus tutoring, both in Searles and in Canvar, Sunday through Thursday evenings. And I can't remember, one of them is always like 7 to 10, and one of them is 6:30 to 9:30, and I can't remember which is which. And so once they announce, you'll get an emails announcing these, and then I'll try to post that here. Okay. By the way, I should try to watch the chat in case people have questions. Why is the chat? Okay. Yeah, I'll try to keep an eye on the chat in case you guys have questions, or just feel free to pipe up just to ask a question. All right. The textbook is this book. I'm going to post the problem set pages. I'll show you like the PDFs of the pages from the problem set. I don't love how expensive these books are. It's pretty easy to find PDFs. This edition was new last semester, and I looked last semester and couldn't find an easy way to find a PDF online. But the 7th edition, you definitely can find pretty easily. So, so yeah, and maybe the 8th is also now in places like this, which I'm sure you know about. If you want any textbook ever. Okay, assignments. Okay, I'm just going to go through all this logistical stuff, and then we'll get to some actual math, at least a kind of overview of the course soon. So yeah, we're going to use Gradescope. I haven't set up the class Gradescope yet, but I will soon, and then I'll probably take you through that on Wednesday or Friday or something. The first problem sets aren't due till next week, so you have some time to get this set up. But it's just an online submission thing, and then the graders can grade, and I can grade and look at stuff. And the big thing is that you're going to want to just have some decent scanning app, and or use your iPad. A lot of students would use like a Notability or whatever or OneNote on iPad and turn their homework in that way, and make a PDF that you're going to like upload. It lets you upload photos, but that's actually more annoying for us for some reason. So I'd rather use PDFs. I'll talk more about this. And then, but what we do is, so there's going to be 2 small problem sets due every week. I put them Tuesdays at 11 and Fridays by 5. Just thought give you a chance to have a weekend night, not have it Friday at 11 p.m. But twice a week, kind of spaced out. Some students think it's going to be midnight, but then Gradescope just makes it weird for me to put midnight as a due time, so I put 11 p.m. So just keep that in mind. And then, like I said, I'll ask you to take some notes, and then I actually have you upload them just to like force you to take the notes, and I'll just spot check it real fast just to make sure you did it, just so that when everyone comes to class, we'll have all watched the videos and we can discuss. If that makes sense. Okay, grading. I just set it up as like 25% for each thing, but here's how my thinking has evolved. Like, I don't give sit-down exams anymore. I don't want to get into nitty-gritty of points. I really just want, if everyone gets an A, that's fine. I've actually, in the pandemic semesters, there's been a few times where it's been close to everyone getting an A at the class, which I don't know how the college feels, but I don't care. If you learn a lot, then that will be reflected in a good grade. And the way that works, the way I do that with the midterms, first that involves being consistent, just like working consistently. I think this, if you kind of stay on top of the problem sets and the class, and then do this, what I'm about to tell you on the midterms, I think you'll be totally fine. The idea is that I will post each midterm on Gradescope, but it'll have like a time limit, like a 4-hour time limit or something, that you can take it. Again, I'm not going to do it as a sit down, but you can sort of take it almost as like a self-test, just like I'll ask you to prepare like a cheat sheet, like notes if you want, and then take the test and then upload that. Then I'll give quick feedback on that and a score. I think I'll give you a score, just like quickly, just what I think your score would be. And then you can, but then after I give you the feedback, I'll give you like a week, and you can talk to anyone, use book notes, whatever, rewrite any problems, and you can get 100% of the credit on that problem. So if you turn in like really nice solutions, I'll have a higher standard probably, because I want you to be nicely written solutions at that point. But yeah, so if you're and so students turn in, I've been doing this for a few semesters, and students turn in amazing stuff, like where they show me they really understand the ideas, and that's great. Then I'm happy to give you a good grade. So there you go. Any questions about that? I don't have all the details up online, but I've written a bunch of stuff over the last few semesters, and I just need to cobble some of it together into some pages because I've changed a few things from last semester. But yeah, hopefully this will all. I mean, hopefully it's reassuring that I really just want you to focus on your learning and not your grade. All right, and then pandemic protocols. I guess I'd written this in the past, but it's obviously this week we're remote, but yes, do not come to class. Like I said, I'm going to stream our class over Zoom always. So if you're sick or have some reason you can't come to class, you could always join remotely. And I do like to do a lot of group work. Actually, the room that we have, Searles 215, is like blackboards on all 4 walls, which I really like because it's great for doing group work. And but you know, that does mean you're like close to students, and so like, you know, you have to let me know if you're uncomfortable in any way. Like it's fine. I mean, it's totally fine if you're, you know, the most important thing is that you feel like you're safe and comfortable with whatever we do. So if something about that group work makes you uncomfortable, let me know. All right. Any other any logistical questions? This is just a list of topics, which doesn't mean that much to you yet, but I just put that there. I will say back at the top of the page, I do have an assignments page set up. Sometimes students last semester were saying that they wouldn't always see the most updated version. So I was just telling people just to reload the page when they get here to make sure that happens. I have it a few times early in the semester and then nobody mentioned it again. So I don't know if it actually is a problem at all. But so yeah, so for this week, I just have some recommended readings to start looking at the book. And then the first problem set is due, like I said, Tuesday at 11 p.m. The second problem set is due Friday by 5 p.m. And then we'll just go from there. I think I might have you watch a video about vectors that I've made in the past for next Wednesday. That's about when we'll be starting vectors. So I'll post that soon. I have a video. I just have to post the link to it. And then if you look at a problem set, I mean, honestly, it's just, yeah, right. I'm just taking stuff out of the book. And like I said, I'll post the actual pages. So here's the pages from the textbook. I got a copy of the 8th edition and scanned the whole thing. Just because I like having everything digitally. And since I couldn't find it online last semester. All right, so yeah. So you'll be able to just look at the problem set and then find these problems and then, you know, write them up, turn them in. Okay. And then I have this handouts page, which like, this is actually stuff, you know, just I've used in past semesters that I'm assuming we're going to use at some point. And I already know, like, I already put this for Wednesday because we'll look at this handout on Wednesday. So you could look at that in advance if you'd like. All right, how's everyone doing? Decent? Okay. Excited to be back? Well, kind of back. Ready for a hopefully more normal semester. Oh, it's interesting. I have students from last semester whose faces I don't think I've ever actually seen because we were always masked in class. So, hi. It's good to see you all. Okay. So I'm just going to give a quick kind of overview of what the course is about. So let me share my iPad screen so I can write on it. Face ID works like half the time and not when you're wearing a mask. Okay, so yeah, so all right, let's see if this works. Yes. Wi-Fi in my office is not good, so usually I would try to connect through AirPlay, but it didn't seem to work. So luckily I had a cable where I could connect directly. All right, so math. So this is just going to be kind of an outline of like what the course is about, and just maybe start putting some ideas in your head, some questions of like how we're going to actually look at everything. And so let's just think about like, you know, single variable. Also, my handwriting is not the best on these things. Well, some people, I do not really like the feeling of the plastic on glass. Some people say they're fine with it. I do have some masking tape on the tip of my iPad pencil to make it feel a little more natural. But let's just think about the kind of stuff. Okay, so single variable calculus. Well, you even start from like actually like pre-calc, you know. That's supposed to be an E, a C, and an A. Pre-calc. So, you know, here we have like everything is like x comma y. We have the xy plane, right? The Cartesian, the 2D plane. Whereas over here, you're going to actually look at more variables. So we'll do, you know, x, y, z, or we'll even use 4 variables sometimes, or we could do n dimensions if we wanted to. Like we could do like some 1,000-dimensional space. Of course, visualizing, we're only going to be able to go up to like 3 dimensions. So, so the way we usually draw that is something like this. So y and z are kind of in the plane of the blackboard, the y and z axes, and you're supposed to think of the x as coming out of the page pointing at your eye, or you're kind of looking from like, you know, from like you're looking into a corner of a room, right? So actually, wait, oh, I have this, I can use the laser pointer. Yeah, so this is like the corner of a room or something. And so in fact, if we were in the classroom, I often point to the corner of the room and it's like that, there's the origin. The x-axis points along the bottom along one wall. The y-axis points along the bottom on sort of the front wall. And the z-axis points up and down, right? And so we're going to spend a lot of time starting getting used to like thinking in 3D, because you're very okay thinking in this realm, right? You've done that a lot, but you haven't done a lot of this. So really, class Wednesday, we're going to just kind of get used to this, some of the things with like distance and, you know, just ways to write things down. When you move on to functions, which is still like pre-calc, right? We have like y equals f of x over here. And over here, but over here we have usually something like z is a function of 2 variables, or w could be a function of 3 variables. So we'll be looking a lot at functions of 2 and 3 variables, and thinking about, we're going to think a lot about how to visualize them, right? Because over here you have just, you know, you'd have some sort of graph like that, y equals f of x. That's just, you know, you're just plotting the points x comma f of x, right? Like some point here is like this could be like the point, if this is like 2 on the axis, this is like the point 2 comma f of 2, right? That's what we mean by plotting. But then what's the analog over here? Well, so now you've got, I mean, it's sort of interesting to think about. So for every point over on the left here, for every point on the x-axis, you've got a corresponding y value, right? So like I pick this x, I get that y. I pick this x, I pick this x, I get that y, you know. So now it's like, okay, there's sort of this plane down here that's like the floor. Does that make sense to people? This is kind of like the floor. And then for every point on the floor, there's, you know, so like some point here, let me just draw lines through this. This is like x and that's y. or maybe I should say x equals a or something and y equals b. And this is the point a comma b. And then we could plug that into some function. And I should probably give examples like, something like this could be, for example, one example we'll look at a bunch is something like x squared plus y squared. That's an example of a function of two variables. But really any kind of thing you could create that used x and y, any kind of expression you could create could be a function of two variables. And so this will be the point, and then we'll have some point in the z direction that's like up here, right? Sitting up in space. Can you guys see that? I don't know if that helps. Maybe you just rather see the whole thing. And so we'll do that for every point. And what's the analog going to be? Well, the analog is going to be a surface, right? So here we get, over on the left, we get, curves in the plane. Here we get surfaces in space. And so you might see something, I mean, it's a little bit hard to draw. It turns out, for example, that this guy right here is a bowl shape. So it's like, it's kind of a parabola of parabolas. So it's like, something like that with the x, y, and z axes coming out of it like that. Okay, so that's a surface. Again, please ask questions. I'm still trying to keep an eye on the chat. If anybody has questions, I've got the chat window open. All right, so that's sort of like the first thing we're going to do is kind of look about, like, try to figure out how to orient ourselves in 3D space. And also, really, we don't have, I mean, we have tons of experience with this, right? We have tons of experience with, you know what all sorts of different functions look like. You know what quadratic parabolas look like. You know what sine and cosine looks like. You know what exponential logarithm functions look like. Over here, all of a sudden, it gets much more difficult because we don't have an experience that we had before. So we're going to think about how to sort of, how we can sort of know that this equation will give this surface. We also have technology, so like even the Google search bar will plot things for you and plot 3D things for you. Like if you went to the Google search bar and typed plot z equals x squared plus y squared, I think it would give you this picture. Maybe I should do that. I'm always tempted to, I always think I'm going to screw up the share somehow if I do this, but let's try it. I'm a technologically savvy human being, right? So let me open a new tab. So if you type like plot z equals x squared plus y squared, look, there it goes. So it's kind of amazing. The Google search bar is actually really powerful. And you can see what we're talking about. I mean, it's hard to see a little bit that like this. So it tells you what the x, y, and z values are from. So the origin is actually right here, because if you plug in 0 and 0 here, you get 0 squared plus 0 squared is 0. So that's the bottom of your parabola, or your bowl shape. And then, but you can type in different things. We're gonna just do this. We could do x squared times y. And it looks something like this. And I don't know that I would have guessed that, although maybe that's something you can, we'll talk about this. I mean, that's what we're going to do. Like by the end of this week, we'll be talking about how to visualize these and how we could have guessed that that shape would be something like that. Or x squared times, I don't know, sine of y. Oh, hello. Again, you can maybe come up with some arguments as to why this is the picture we get. And these are still kind of separated. You can really put things together, like if I did sine of x times y. Let's see if Google can handle this. Oh, that's weird. You know what? Oh, it's doing sine of x. Oh yeah, see, it's actually telling me. I knew this couldn't be right because it's different along the x and y axes, but in this function, x and y have the same they play the same role. You could switch them. Wow. Okay. So things get kind of crazy. I don't know if I can. Oh, I can actually. I can actually reduce this maybe to like. Come on. Why isn't that working? Now I can't get away from this. Stop it. Oh, this didn't change either. I don't know. Somehow I don't know how this works. Okay, we'll have to play with that. I think it can change because it looks better if you zoom in on it, it looks less insane. But all right, we'll also use Mathematica where you can really control all this stuff precisely. So I'll start showing you some of that too, because I don't really know how this interacts with. And there's also, what's the other one? Desmos that a lot of people like. I don't know how it does with 3D stuff, but I just love that the Google search bar will basically be a calculator and a graphing calculator. So, all right, back to the notes screen. Hopefully it'll work. Okay. Okay, so we'll get into that. But the point is like you shouldn't feel confident yet because we just probably haven't done much of this in your life, and so we'll start to get used to that. Okay, but what about if we get into calculus now? So we have like differential calculus. And a lot of this course is going to be just figuring out like what the analogs are in higher dimensions of our concepts that we know from single variable calculus. And some students ask me like, do I have to really know all my calculus like down pat? Like, do I need to remember all my integration techniques? Do I need to know Taylor series? The answer is no. That's actually not what this course is about. It's not about technical proficiency with that stuff. I mean, it's certainly good if you can do that, but since the idea is more conceptual about how to move into higher dimensions, then really what you're talking about is we're going to use simple examples to try to see how the things translate. It's not so much going to be about using like super complicated examples. So actually, let me sort of do this again. So single variable versus multi. Okay, so we have these concepts in differential calculus, right? We have the derivative. What are other words that come to mind? I don't know if people are willing to talk or put in the chat. When you think about like the derivative, like geometrically or like conceptually, what is the derivative measure? Let me make this somewhat interactive. Someone say something or put something in the chat. What's the derivative geometrically? Like on a graph. Did I mute everyone or can I not hear people if they're trying to talk? Oh, somebody put it in the chat. Is anybody trying to talk and I'm not hearing them? Because that's possible. Do I have the right audio? I just realized I haven't heard anybody say anything. Oh, crap. I see. I'm sorry. I have my AirPods in, but I don't think that's been playing to the AirPods. Sorry. I don't know if people have been saying something. Can someone just say hi right now and see if I actually hear you this time?
Hi.
Ah, hi. Okay. Were people talking before and I wasn't hearing them?
I don't think so.
You don't think so? Maybe I would have heard it from the speakers on the computer. Okay, but at least it's in my ear now. Okay, and I see in the, okay, sorry about that. So I see in the chat, yes, slope of tangent line and rate of change. Those are exactly things I was looking for. So yeah, we can think of this geometrically as if I draw, you know, again, if I have a graph, so, if I have a graph and I'm at a point on that graph, then say at this point or something, then there's this tangent line right there. And so, yeah, we have here like y equals f prime of x or dy dx. And that's the slope of the tangent line. Or, and then also conceptually, it's a rate of change, which is good. That's exactly what it is. It's the instantaneous rate of change. You know, if you change x a little bit, how do you change, you know, y and z? So, oh man, sorry. So, so this is geometrically. This is conceptual. It's the rate of change. It's instantaneous, I should say, rate of change. So if you change, it's really if we increase x a little bit, how does y change? Or if we, let's just say if you change x a little bit. How does y change? Right, that's kind of the question that it's answering. Okay, so that's all the single variable ideas of, I mean, not all of them, but that's some of the single variable ideas of the derivative. And then but this is like at a point, right? This is like the derivative at a point. I mean, there's like the derivative function, but we have the derivative like at a specific point is kind of what we're talking about here. So now if we go over to the multivariable world, which that's really kind of what we want to do is like figure out like what's the analog, right? So, and you might be able to start to guess like at least geometrically. So now let me try to draw like a surface. So what I tend to do, let's do something like this. Like I'm going to think about it being like over this little patch of the XY plane. Remember, this is like X, Y, and Z. And so I have some like, points here, and I'm just going to sort of like connect them in some strange way. And then just maybe think about like, that's supposed to be like some kind of like, it looks like a crumply napkin kind of held over, you know. So that's like some surface, right? That's a terrible drawing. I'm gonna, I'm annoyed with myself, so I'm gonna try that again. In fact, I don't know, so I probably need some, I mean, almost something like the bowl shape or something is probably almost better here. But in fact, yeah, let me just, but you can sort of see what a generic surface would look like. Let me just draw the like bowl shape, because that's a good so that's sort of a bowl. And then if we pick some point in the XY plane, oh, let me have that color coordinated, so that's supposed to be purple, but if we pick some point in the XY plane, again, like A comma B, and we go up to the surface, then what's going to be the geometric analog of just the tangent line? Can someone guess what the geometric analog of the tangent line is?
Is it like a tangent surface?
Yeah, yeah. I mean, in fact, but it's a straight thing, right? It's like a linear thing. Like this is the sort of, over here we have the best line, the line that sort of just barely touches at one point, right? And so you're going to have something like that over here. It's kind of hard to draw, but you can imagine it's sort of like a tangent plane. So you can imagine that at every point on a surface, there's a plane that sort of like just barely touches it, right? Just barely tangent to it. And so we have to think about what that means. But I mean, in some ways, we could think of the derivative as encoding the tangent line, because we know the point, we know a point on the tangent line just because it's the same point on the curve. And then the derivative tells us the slope. And so somehow the derivative information, whatever the quote unquote derivative over in multivariable end is, we want it to somehow give us the equation of the tangent plane at a point. So the derivative should, maybe I'll put it down here, the derivative should, whatever the derivative is going to end up being, it should give us the equation of the tangent plane at a point. And we'll talk about equations of planes and stuff, you know, before we get to this, to set it all up nicely. On a surface, right? So that's one thing that the derivative should be sort of geometrically. Conceptually, so again, this is sort of geometric over here. Again, we're just going to put in quotes derivative geometrically. So what about conceptually? What do you think is the analog of an instantaneous rate of change, or just a rate of change in general? Right here, we change x a tiny bit and we can see how y changes. When we have, you know, z equals a function of x and y, well, it gets a little more complicated, right? I mean, oh, I like so many direct messages. Maybe the area of the tangent plane. That's interesting. Yeah. It's something about the tangent plane, right? It's something about, I mean, there's definitely a connection here, because like if you change x a tiny bit, over here, how does y change is involves with the tangent line, right? Because it's like you go over x a little bit, you change y a little bit, and that's better the smaller delta x is. But do you see that sort of you have more freedom now over in this, in multivariable end? Because you can change both x and y a little bit. So change x and y a tiny bit. How does z change? And we're going to certainly talk about that. What am I doing? So, how does z change? We're certainly going to talk about that, like, you know, about what happens if we change x and y a tiny bit. But if we want to move that towards something instantaneous, like over here, it's really the limit. It's, you can almost think about like f prime at, or actually, let me just to be a little more, we can write dy dx, which is the derivative, is the limit as delta x goes to 0 of delta y over delta x, right? I'll try to write that a little better. And so if you're letting delta x and delta y go to 0, there's the point I'm trying to say is that like there are questions, there are complicated questions here, like, you know, how do we let it seems like maybe there's different ways to let delta x and delta y go to 0. Like they could go to 0 at the same rate, or delta x go to 0 twice as fast as delta y or something, you know. I mean, the goal of today is to give you more questions and answers, right? And get, you know, and get some sense of how, you know, what is it? Is it delta z over, you know, what? Like, what's the question? Like, it's the limit as what goes to 0? That's a question mark of delta z over what, you know, like, anyways, these are questions and we'll talk about this. We'll answer this, but it is interesting. There's interesting questions there. Okay. But in the interest of time, I think I'm just going to move on to talk a little bit about integral calculus. Right, so we have single and multi. Just doing this whole 2-column thing today. Sorry, I'm not one of these people with beautiful iPad handwriting. I'm impressed when I see problems with stuff. I can write beautifully if I write really slow, but during class I can't really do that. Okay, so integral calculus, we have something like the integral from a to b of f of x dx, right? And what does that represent? Someone tell me in the chat or aloud, like. This is our function. Then what is that? Yeah, area, the area under, it's sort of under the, it's the area under the graph and above the x-axis, right? And so there is a way to interpret that if the function dips below the x-axis, then like the area down here is considered negative, right? So there's this whole interpretation, it's a signed area. I also want to put like area in quotation marks because, yeah, under the graph and above the x-axis. And so you could certainly imagine that there's something similar now going on over in multi-land, right? Like, it's a little daunting though, but it's kind of amazing how much we're going to be able to piggyback off the ideas of single variable calculus. The one thing I always say is that like human beings are not very intelligent, and we've only had a few good ideas in history. And so like, you know, in single variable calculus, derivatives integrals is a good idea. And so we just want to like exploit that as much as possible. So let me do one of these. Oh my God, I'm really bad at this. Okay, so this is some surface sitting above some region of the plane. So this is a region of the XY plane, I should say, like, right? So like we're gonna talk about the XY plane, the XZ plane, the YZ plane, but the XY plane is like the floor, right? So we have the region of the XY plane. Usually we call this something like R, right? And you can guess that the analog is going to be the volume underneath the surface and above the XY plane, right? So we're going to have something like the double integral. It's usually written, I think our book actually sometimes uses just one integral sign, or uses just one integral sign. I kind of like using two integral signs. So instead of from a to b, it's the integral over r of f of x, y. And there's also something weird here, like you have the dx in single variable calculus represents some tiny sliver of the number line, right? And here we're going to have some tiny sliver of the region, and that's going to be called dA. And we'll talk about why this makes sense, because there's like the whole Riemann sum idea of like little tall thin rectangles that you have over here in the single variable case. And we're going to have something similar, but we're going to have little like skyscrapers, little 3D skyscrapers that build up the volume underneath. And so, yeah, so this is an area over on the left, and this is a volume over on the right, okay? But what I want to say is that things get more hairy when you go to like triplet. When you go to like, so these are called double integrals. But there are things that are called triple integrals, which are integrals of, you know, of some function of 3 variables over some region in space. So now I use dV for volume. dA was for area, right? This is like a little piece of volume. This is some region in space, some 3D region in space. And, you know, the interpretation is a little weird then. It's like, well, what on earth? I mean, it could be considered as like a 4-dimensional volume. It's just hard, we can't picture it though, right? So there's like some surface, like if you think about this case, right, this is really a 2D surface in 3D space. This is a 1D curve in 2D space. So if you go up, you could have a 3D surface in 4D space. I mean, it gets hard to picture. And then there's like there's something called a hypervolume, but we're gonna need conceptual ideas, because like trying to picture this as a 4D volume is pretty not useful. So we need a conceptual interpretation, and that's what we're going to talk about, of like, what is an integral actually measuring about a function? Area is not the only sort of answer to that. There's other ways to look at even a single integral besides just measuring area. You can think of it as an averaging thing. It's kind of, we'll talk about that, but like the average value of a function involves the integral. And so we can think of double and triple integrals as averaging a function over a region of the XY planar of space. But it's definitely like hard to think about. And then actually it's like, you know, this can be generalized to double and triple integrals, but there's actually other things that we're going to talk about which get even more crazy, called like line integrals, where we're integrating along some path in the planar in space. We'll talk a little bit at the end of the semester about surface integrals. Like if I had some function that was defined on the surface of the Earth and wanted to integrate that function over some patch of the Earth or something. And so there's other, again, and so we're going to need this conceptual interpretation to be able to even try to understand like what these things would be measuring. And so that's kind of like going to be the goal there. In some ways, this can be considered a separate thing from like the differential integral calculus, because it's more like this, what's called vector calculus. Maybe I'll just say like, yeah, this is called like quote unquote vector calculus. But we'll definitely get to it at the end of the semester, at least the line integral stuff, and maybe a little bit of surface integrals. Although you don't really need that stuff unless you go on in physics, and then you'll do a ton of it in physics. So, but it's interesting to talk about. Okay, so that was my spiel. I will, like I said, I'll post the video of this, and then I'll also, maybe I'll post these notes too, but probably a good idea if you were writing stuff down along with this, just to keep yourself, at least for me, it's hard for me to just watch someone writing. If I write it, it keeps me more focused on what's going on. Okay. Any questions before we go? Oh crap, I was going to show you Gather and I don't have time now. I do officially have office hours right after this. So if you want to ask questions, you can stick around. I'll just show you Gather on Wednesday. You can click on the link. Actually, we have a couple minutes left. Where was that? Maybe I'll do the super quick version of showing you this, which is, yeah, this is kind of cool. I will say one big thing is that this doesn't work on Safari Renderer very well. It works on Chrome, but how do I grab this access? Oh, there we go. So this is like, students have told me it's like Pokemon. I don't get that reference because I'm too old, but like, to me, it's like Legend of Zelda or something, like the old 2D. So students can come here. You can come here with your little avatar. If somebody wants to click on the link and come here, they can. You come here with a little avatar, and then when you get close to people, it comes up with audio and video. So you can move around and talk to people. And so since I'm teaching 3 different classes this semester, it's good for me to have the ability to talk to students from different courses. And these are all little private rooms, and they actually have like a whiteboard you can use and start like drawing on and talking. That's supposed to be a high. It's a very abstract art looking high. So, but you can also share this link and like to an iPad and then write on an iPad, and then it's like a shared workspace that anybody can see. So you can, sometimes if like I do group work, we can go into a room like this, although it's again, there's only 25 students allowed. Nobody's being brave and clicked on this link. It's underneath the office hours and study group. I don't see any students coming here. But anyways, we're out of time. If you want to hang out to ask questions or play with this Gather for a few minutes, this is where I will be for office hours this week. But I'll try to keep the Zoom open also, just in case. But I'm hanging around. So yes, everyone, have a good day. Welcome to the class. Stick around if you can, and if you want to ask questions, but you may have another class right after this. And thanks, good to meet you all. Hopefully, I'm excited to see you in person. Take care, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Hey, Professor. I was
Hi.
just sticking around to tell you, I probably should have told you this in the beginning, but I actually have a concussion.
Oh,
I'm
no.
not entirely sure what that will entail.
Yeah,
But I just wanted to let you know.
no, please. Let me know whatever you need. Like,
So far,
I'm-
I've been good. Like I'm able to watch like now, like I mean, because I've been in 2 classes now, but now I'm getting slowly a headache. But actually, I think this has been totally fine. The